Welcome to the MAS Chemverse channel, your guide through essential courses like pharmaceutical chemistry and medicinal chemistry.
Please like and subscribe my channel before starting the topic. In the last class, we started diuretics. We discussed up to the furosemide, that is the high ceiling diuretics. Now one more thing, it will be remain in the high ceiling diuretics, that is the ethacrynic acid and another drug. First we will go for the ethacrynic acid. Basically it is having the phenyl acetic acid as the basic structure. It is called as the phenyl acetic acid. Then at the second position having halogen, third position also having halogen. That carbonyl group here attached to the double bonded carbon CH2. Here the carbon will be there. Here it will find the another CH2 and CH3. Total 4 carbons here. In this case, this is having the double bond, this one. This group is called as the acrylyl group. Which one? Especially this one. This is the structure of the ethacrynic acid. Already we know the uses of this one. It is used in case of edema, and as well as it is used as the water pill, that is the diuretic, and also used in the hypertension. These are all the uses. Okay, already I told the mechanism. It prevents the reabsorption of the sodium. Okay, this is about the ethacrynic acid. Then what is the SAR of this one? Structural activity and relationship. Just see in this case, at the first position, I will give the numbering. First position, it is having the acetic acid. This acetic acid, it is necessary for the action. That is one thing. Another thing you might be observing here, second and third position. What is the second and third position? Both the position, it is having the electron withdrawing group. Then resonance effect dominating over the inductive effect, what we studied in case of organic chemistry too. That's why it will be act as the donating. But you consider it is the electron withdrawing group only. Always remember in the SAR, electron withdrawing group increases the diuretic action. Diuretic action going to be increases. But in this case, if you will be substitute with any other group, activity it is going to be decreases. Then see here what I told here. Carbonyl group attached to the double bonded carbons. This acrylyl group, it is playing the vital role because this acrylyl group binding with the receptors. Always this acrylyl group, it is going to be bind with the receptors with the particular enzyme which is present in the renal system. Okay, because that enzyme it will be having the mercapto group, SH group. This acrylyl bind with SH group. So what it will be do? It prevents particularly the action of that particular enzyme. That is the reason it will be act as the diuretic. It means what here? This acrylyl group, it is playing the vital role. Vital role in case of what? Diuretic action. Because the diuretic action depends on this acrylyl group. Okay, that's why it plays the vital role. This is the SAR of this one. Okay, the acid group is necessary and both the chlorine halogen is necessary because withdrawing group always increases the effect. Then acrylyl group, it is bind with the receptors, especially in the receptor having the mercapto group. Okay, in the renal system, then it will be act as the diuretic. This is about the ethacrynic acid. The other drug which is comes under in the diuretics, that is the bumetanide. When it comes to its structure, it is having the phenoxy group at the para position, acid group at the first position, and one of the shoulder it will be having the sulfonamide group. The another shoulder it is having the amine that will be attached to the butyl group. This is the structure of the bumetanide. The bumetanide also it is helpful as the diuretic, used as diuretic, and also useful in the treatment of edema and also useful as the antihypertensive. And when it comes to the its use of this particularly bumetanide, it's having the diuretic action more than furosemide. Bumetanide diuretic action is more than the. Next we'll go for the thiazide and thiazide like diuretics. The next class is the thiazide and thiazide like diuretics. In this case I will draw the main two structures. The basic structure is the benzothiazine. Here it is having the sulfur dioxide group. Here one nitrogen and here one nitrogen. Here it will be having the electron withdrawing group, and here it is having the sulfonamide. This is called as the hydrochlorothiazide. When it comes to the another structure, that is the chlorothiazide, it is also having the benzothiazine, and here the nitrogen, here one more nitrogen, but here it is having the double bond. Sulfonamide group, electron withdrawing group. This is called as the chlorothiazide. What is the difference between this hydrochlorothiazide and chlorothiazide? I'll give the numbering 1, 2, 3, 4, 5, 6, 7, 8. For this also 1, 2, 3, 4, 5, 6, 7, 8. Okay, this chlorothiazide and hydrochlorothiazide, what is their main mechanism of action means? Prevent reabsorption of sodium and chloride ions. Okay, prevent the reabsorption of sodium and chloride ions by increasing the output of urine. This is entire thing, it is going to be occur this mechanism in distal convoluted tubules. Prevent reabsorption of the sodium and chloride ions to increase the output of the urine. Again, when it comes to the uses will be similar to the last, ethacrynic acid and furosemide what we discussed. Okay, now when it comes to the SAR of this one, because SAR is very important in this case, thiazides and as well as the thiazide like diuretics. We'll go one by one. This particularly sulfonamide groups, what you are going to be observed this group necessary for diuretic action in both hydrochlorothiazide and chlorothiazide. Which one? Sulfonamide, sulfur dioxide. It is necessary for the diuretic action. Okay, when comes to second position, the second position here we can introduce, just listen here, we can introduce small alkyl groups. It means what? No change in action means diuretic action. Okay, but if you introduce the large alkyl groups, remember that if we introduce as the large alkyl groups, the activity will be decreases. Okay, small alkyl group, no change in the action, but large alkyl groups decreases the action. Understood? This is about the second position. Now see in between third and fourth position here. Which position? Third and fourth position. Third and fourth position here 10 times less potent than hydrochlorothiazide. Means what here? No double bond. The saturation of this particularly, the saturation between third and fourth position saturated, that is 10 times more potent than chlorothiazide. It means it is more diuretic compared to the hydrochlorothiazide. Okay, which one? Hydrochlorothiazide. This is about the third position. Okay, third and fourth position in between this. If you might be think, if you are any substitution, which position? Fourth position, fifth position, and eighth position. Any substitution decreases the activity, that is diuretic activity going to be decreases. But one other thing we forgot here, especially this position, third position. Okay, third position, it is responsible for potency and duration of action. Duration of action means substitution at the third position. It will be changes the potency of the drug, means either decreases the diuretic action or increases the diuretic action. But what we observed, there is no substitution, the activity will be good. If we will be do the any substitution here, okay, the potency also decreases, the duration of action it might be increases. Okay, that is why this third position, it is responsible for the potency as well as the duration of action. Both is not going to be increases. If potency increases, duration of action decreases. If potency decreases, duration of action will be increases. That's why finally what we found in this case means the third position, there is no substitution, but it should be saturated, then it is more potent. Okay, more potent, because the presence of particularly here hydrogen on this nitrogen means saturation between third and fourth position, it is more potent, that 9 to 10 times more potent than the chlorothiazide. This is another. Then what I told, sixth position, it is having the chloro group. What I told, whenever the electron withdrawing groups are there, remember, especially in the medicinal chemistry, 99.9%, whenever electron withdrawing group is there, increases the activity. Remember this, any electron withdrawing groups, because they are toxophoric in nature. And sulfonamide, removal of this sulfonamide, what happens? That may be removal of this sulfonamide, removal of this group produces less active sulfonamide group. Removal of this, it produces, it is less active, or it won't have any action also sometimes. This is about the SAR of the thiazide and thiazide-like diuretics. Okay, remember, we should not disturb this sulfur dioxide group. Here you can introduce the small alkyl groups, no change in the action, but large alkyl groups decreases the activity. Third position, responsible for the potency and duration of action. Usually when we will be introduces any alkyl group, here usually the penetration power will be increases of that particular drug. But what happen, potency also increases, but the duration of action, it is going to be changed. That is one thing. And here presence of the double bond, less active. No double bond, this is less active, but it is more active because there is no double bond, it is saturated. 9 to 10 times it is more active, this particular. Then fourth position substitution, fifth position substitution, eighth position substitution, they are going to be decrease the activity. This sulfonamide group, removal of this, it produces the less active or no active drug. This is the SAR of this thiazide and thiazide-like. Next we will take the hydrochlorothiazide. Structure of hydrochlorothiazide, we will go for the synthesis. First I will write the structure, then it will become easy for us to write the synthesis. Same, benzothiazide. Hydrochlorothiazide means it is saturated because it is more active drug. Here it is having the chloro group, here it is having the sulfonamide group. This is the structure of the hydrochlorothiazide. Now we will go for the synthesis. The synthesis of hydrochlorothiazide, it will start with the 3-chloroaniline. Remember this, the synthesis start with the 3-chloroaniline. It's the aniline because when it is having the amine group, it's called as the aniline. Third position, it is having the chloro group. Now it will be react with the chlorsulphonic acid. Here chlorsulphonic acid by the removal of water. Now see at which position it is going to be introduced, the sulfonyl chloride group. Here this position substitution is there and this position also substitution is there. That's why the empty positions are these two, because these two are the free positions. That's why here one sulfonyl chloride and here one sulfonyl chloride, that is SO2. What it introduces? Sulfonyl chloride group introduces here one and here one. The next part, you might be thinking here, you might be observing here, SO2 is there, but here NH is there. Here also you can see SO2 is there, here NH is there. Means what it is going to be indicate? It required the amidation, means we have to treat with the ammonia. See in the next step, we are treating with ammonia. That process is called as the amidation. Remember this, what it is called? Amidation. That is introduction of the amine group. Introduction of the amine group, what it produces? See here SO2 is there. Okay, one of the hydrogen and one of the chlorine goes out in the form of 2 moles of hydrochloric acid. So what it will be remain here? SO2, then NH2. Here also SO2, I can write like this, SO2 NH2. Okay, here it is remain which group? Amine group. Here chlorine group. Just see what thing new amidation, what we got new thing here, this amine group and this amine group. These two are the new thing. Here the sulfonyl chloride group, then it undergoes the amidation to produce the amino group. Okay, in the next step you can see what we required in the next step. We required this carbon, is it right? This carbon we required. For that, always whenever the carbon we required, we have to be react with the formaldehyde. From that only carbon will come. Okay, then carbon will come means what it will be relieve? It relieves the water. Okay, now what happened? It undergoes the cyclization with the help of formaldehyde to give the hydrochlorothiazide. Here you can see SO2, then here NH, this NH, here extra thing what will come? This carbon. Okay, this carbon will come here, this carbon. Then next what it will be have? Amine group one more, it is remain in the form of NH. Then here chloro is there, 6th position. 7th position what we are having? Sulfonamyl group we are having. Okay, this is called what? Hydrochlorothiazide. What new thing we got in this structure? It is cyclized. Introduces the carbon with the help of what? Formaldehyde. Okay, just remember that, don't be confused. Initially 3-chloroaniline required. It undergoes the react with the sulfonyl chloride to introduce what? Sulfonyl chloride groups, that is SO2Cl. Here one and here one, SO2Cl, sulfonyl chloride. Then it undergoes the amidation by the relieving the water. Then what it will be introduces? Here one amine group and here one amine group introduces. Next step, we require the cyclization. The new carbon from where it is coming? This carbon is coming from the formaldehyde. What it is called? Formaldehyde. Then it easily undergoes the cyclization to produce what? Hydrochlorothiazide. Okay, hydrochlorothiazide is more potent than the chlorothiazide. One more drug in this case, hydroflumethiazide. 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 What is the difference it will be have? Only the difference is there here. It is having the trifluoromethyl group. This is called what? Hydroflumethiazide. Okay, it is the derivative of the hydrochlorothiazide, but what is the difference is there? Instead of chloro group, it is having the trifluoromethyl group. What it is having? Trifluoromethyl. That's why it is called as the hydroflumethiazide. Okay, this also used as diuretic. It is also useful in case of what? Edema, and it is also useful in case of hypertension. These are the uses of this. Okay, I think you might be getting little bored. Huh? Chemistry, you should not be get bored if you involve in this case. No, when you will be try to understand the concept, it will look very easy. Okay, don't be get bored. Next we will go for the potassium sparing diuretics. The name itself indicate it's sparing the potassium. What is the mean by this? Sparing the potassium. It means it is not going to be excrete the potassium. Without excreting the potassium, what it will be do? It is act as diuretic. Understood? Without excreting the potassium, it is act as diuretic. That's why it is called what? Potassium sparing diuretics. Potassium sparing diuretics, what they will be do? They prevent the excretion of potassium. But what they will be do? But they increase the excretion of sodium and water. This is the potassium sparing diuretics. What they will be do? They prevent the excretion of the potassium but increase the excretion of the sodium and water to act as the diuretic. You might be get one doubt. Why it is sparing the potassium? Why it is leaving the potassium? Why it is not excreting the potassium? The reason is very simple. We might be studied the biochemistry. Potassium is required for the mini metabolic process. Otherwise, if potassium is excreted from our body, then what it produces? If excreted means what produces? Potassium excreted means what? It produces one disorder that is called as the hypokalemia. Okay, hypokalemia condition. It is very dangerous for the human being because if we lost the constituents like the potassium, the metabolic process, whatever the metabolisms involved related to the potassium, blood clotting you take, other digestion process you take, and other things also you might be take, all the things they are going to be stopped. That's why when the mechanism will be start, our body mechanism, heat reduces, our body become cold, will become ice, then we have to be take the ticket. Okay, see, that much meaning is there inside. Now tell me, it is interested or not? Just it depend on us. Now potassium sparing diuretics, in the last class already I told, they are classified into two types. You understood what is meant by potassium sparing diuretics now. This action it is produced by, first one is the produced by this action by inhibiting which channel? Sodium channels. Inhibiting the sodium channel. For inhibiting sodium channel means what drugs I told? Triamterene and amiloride. We'll go for the triamterene now. Okay, sodium channel inhibitors. Sodium channel inhibitors means inhibit the sodium. Understood? Inhibit the formation of the sodium along with excretion of the urine. Okay, that's why these are called as the sodium channel inhibitors. Which one? Triamterene and amiloride. Okay, then I will write the structure of the triampterin first. We'll go for the triampterin. Triampterin structure, it is look like a pteridine. Pteridine, where we might be studied, you might be remember that, where we studied the pteridine, folate reductase inhibitors, like dihydrofolate reductase inhibitor, tetrahydrofolate reductase inhibitors. In that you might be know folic acid. Folic acid, it is required for the bacteria. The bacteria will be grow like anything. In case of sulfonamide, you might be studied. If we stop that particular pteridine, we will be prevent that conversion from the dihydrofolate to tetrahydrofolate, means pteridine ring. Modification on the pteridine ring, it prevents what? It is act as the what? Antibacterial in that case. Now here also structure, it will be look similar to the pteridine. We are modifying whatever the basic structure present in the receptor in the microorganism, we are taking like that only, the receptor structure. Minor modification we are doing. That's all. In the same way here also triampterin. Triampterin, you can see here, it is composed of, here you might be think it is the structure like a pyrimidine. Is it right or not? It's like a pyrazole structure, piperazine structure, this one. It's like a pyridine. Total how many? 4 nitrogens are there. Okay. Then remaining all what? Here also amine group. Here also amine group. Here also amine group. That's why what I told, the structure is look like a pteridine. This pteridine basic ring present in the folic acid. Okay. Now see this, what is the use of this one? Same use as it will be have. It inhibit the sodium channel. That's why inhibit the sodium channel means what it will be? What it will be indicate? Used as diuretic. Then another useful in the oedema. No production of the salt. No production of the salt means what? No oedema. Oedema means what? Retention of the salt and water. But it preventing the sodium channel only. No production of the salt means no oedema. Helpful in the treatment of oedema. And it is reducing the sodium. It indicates that it is useful in case of what? Hypertension. Used as diuretic. Used in oedema. Used in hypertension. These are the uses of this one. When you see the amiloride, it is little different when compared to the triampterin. Now we'll go for the amiloride. It is also having the pyrazine structure. The pyrazine either side, it will be having the amino group NH2, NH2, NH2. Here it is having the chloro group halogen. Here it is having the carbonyl group. That carbonyl group attached to guanidine structure. This is called as the amiloride. Okay. Here it is having the guanidine attached to carbonyl group and pyrazine having the 2 amino group and 1 fluoro group. This is called as the amiloride. Amiloride uses also same. It also going to prevent the sodium channel. Okay. Now next go for the aldosterone antagonist. Another type of potassium sparing diuretic is aldosterone antagonist. Remember this. What happened in this case? If the aldosterone increases, sodium increases. The sodium increases, blood pressure increases. What it will indicate? Produces the symptoms of oedema also. This is BP is responsible for the oedema. That's why what we have to be use aldosterone antagonist. Okay, antagonist. This antagonist is what? Example only one we have, that is called as the spironolactone. Spironolactone, it is look like the steroid moiety. You might be understood this. Aldosterone is present in our body means aldosterone increases means what? Sodium increases, BP increases, produces odema also, BP is responsible for the odema also, like that. It is going to be, all the things will be going to be increases. That's why we have to prevent this particular aldosterone. For that, what we are using? Spironolactone. Spironolactone is the steroid moiety. Steroid nucleus is the basic structure. Remember, what is the basic structure it have? Steroid nucleus. Here you can take spiro compound. This is called as the spiro moiety. Spiro. Then this spiro is present at the 17th position. This is the 17th position of the steroid. Here one methyl group. Here one methyl group. Here it is having the hydrogen. And here also having one more hydrogen. Here it is having the sulfur along with carbonyl methyl group. That is the acetyl group. SCOCH3. Okay. This is the structure of the spironolactone. Okay. Basic structure, what is present in this case? It is having the steroid. Cyclopentahydrophenanthrene ring, that is steroid nucleus. Here it will be having the sulfa acetyl group. Then here having the ketonic group. That's why it is called as the lactone, because it is having the spiro compound here. That's why this is the spiro and this is the ketone. That's why what it is called? Spiro and ketone. It is called as the spironolactone. Remember this. Spiro cheat also available. This is the spiro cheat, what we studied in the organic chemistry 1, spiro. Because here directly attached, no bridge between this carbon and this carbon. With the single carbon, 2 rings are attached. That's why it is called as the spiro. Lactone, it is the ketone. Here also ketone. That's why it is called as the spironolactone. This spironolactone, what it will be do? It prevents the aldosterone. Otherwise, I told no, aldosterone increases means sodium level increases in our body. Sodium level increases means blood pressure increases. That all the things lead to the odema also. That's why this particular aldosterone antagonist, by sparing the potassium, means without increasing the potassium, increases the excretion of the sodium and water. Because it prevents the sodium. Sodium goes out, water also goes out, but the potassium remains. Okay. The last one is the osmotic diuretic. Last class in the classification. Osmotic. What example I given? I given the example is the mannitol. Just take mannitol structure. CH2OH, CH2OH. Then along with that, what they are having? 2, 3, 4. See? OH, 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 OH. Remaining thing is the hydrogens, hydrogens, hydrogen. This is the structure of the mannitol. Mannitol, what it will be do? It increases the flow of urine. Okay, without affecting sodium and chloride excretion. This is very important. Osmotic pressure, you might be studied in the PP. By producing the osmotic pressure, it going to be increases the flow of the urine, but without affecting the excretion of the sodium and chloride ions. Okay, this is called as the osmotic diuretic. Example is the mannitol. Okay, thank you very much. Have a nice day. Please do one thing, like and subscribe. Next week we will be come with the next topic. Thank you very much.